Okay, so first we will discuss about the types of motion and various equations of motion. Types of motion, types of motion and equations of motion. Equations of motion. So basically, there are two types of motion. One is called uniform motion, and another is called non-uniform motion. Non-uniform motion. So uniform motion means velocity is constant. Velocity is constant. That means what? Same speed and same direction. Same speed, same direction. Same speed, same direction means velocity is constant. That means if a particle is going, let us say if a particle is going in this direction, so this is constant. You can write this as vector in general. For example, in 2 dimension, 3 dimension, you have to write vectors as vector symbol. But in case of 1 dimension, you can simply write v because plus minus sign gives direction. But in general, you can write v vector. Okay, so motion can be uniform means velocity is constant. V means velocity. V means velocity. V vector means velocity vector. So if velocity is constant, so you should note that acceleration is dv by dt. So if velocity is constant, so acceleration is 0. Because a differentiation constant is 0, so acceleration is going to be 0. So if acceleration is 0, it is a uniform motion. Acceleration 0 means uniform motion. But note that acceleration 0 may mean velocity constant, but sometimes velocity can also be 0 because 0 is also a constant. Or it can be some other constant other than 0. Constant but not equal to 0. For example, 2 meter per second. That is motion, of course. It is motion. Okay, and this is rest. So velocity is constant means not just only motion, it is uniform motion. Uniform motion. Okay. So velocity constant means uniform motion. Velocity 0 means rest. Okay. So in both cases, acceleration is 0. In both cases, acceleration is 0 because 0 is also a constant. Okay. Right. 0 is also constant. So whenever they say acceleration 0, it can mean any of these things. It can mean either rest or uniform motion. Rest or uniform motion. Okay. So if the body is going with constant velocity, direction is not changing, speed is not changing, then it is simple formula is there. Speed equal to distance by time. That's the only formula we have to use. The only equation that we have to use is, let us say if a body goes a distance of x or displacement x. So speed is equal to distance by time or velocity is equal to, if you take velocity then it is displacement, x can be plus minus, but if it is speed then x will be distance. So this is the only formula which we have to use. Sometimes they have to calculate distance, distance is speed into time. Sometimes you have to calculate time, so time is equal to distance by speed. Same formula, whatever you want to calculate, you can calculate that. Okay, that's the only one formula, speed equal to distance by time, which everyone knows, speed equal to distance by time. That is uniform motion. But when it comes to non-uniform motion, in that case things will be different, because now non-uniform motion means velocity will change, velocity will not remain constant. So in this case velocity is going to change, velocity will change. That means velocity will not remain constant. Velocity vector, I can say velocity will not remain constant, velocity will change. So there will be acceleration, acceleration will not be 0, some acceleration will be there because velocity will change, right? So acceleration will be there. So suppose if there is a body going with a some speed, right? So there can be different ways, acceleration can happen. Speed remain constant, let us say speed remain constant, but direction changes, but direction changes. Speed remains constant but direction changes, right? So that means velocity will change. In this case there will be acceleration. Another case can be um, direction same but speed changes. Okay, so speed speed changes but it is same direction. Direction is not changing. Direction does not change, right? But speed changes. In first case speed does not change, direction changes, or both can change. Both speed as well as direction, both changes. Both changes. So when both the changes or any one of them changes, that is what we say velocity is changing. Okay, because velocity involves both speed and direction. So if any one of them changes, there will be acceleration. So that is non-uniform motion. But now in this category also there are two type of categories in non-uniform motion. What are those two categories? What are those two categories in non-uniform motion? One category is called uniformly accelerated motion. Uniformly accelerated motion. And another category is called non-uniformly accelerated motion. Two types. So uniform means non-uniform motion means accelerated motion. You may also say that this non-uniform motion means accelerated motion. There is a acceleration, so it is a accelerated motion. So accelerated motion can be of two type. One is the acceleration is uniform. Uniform means acceleration is constant. Another called non-uniform means acceleration is not constant. Okay. So uniform accelerated motion means acceleration is constant. Acceleration is constant. In this case, acceleration is not constant. Acceleration is not constant. So in NEET syllabus, both these type of motions are also there. Uniformly accelerated motion and non-uniformly accelerated motion. Okay. So, but generally these type of questions are coming mostly. But here also non-uniformly accelerated motion questions also comes, for which without integration differentiation you cannot solve that type of question. Or you have some idea of graph, you can solve. That also, if the graph is a straight line, you can solve such problems. But otherwise you cannot do. You must know integration differentiation. That is why first we discuss integration differentiation. Now we can take up questions, because we have discussed integration differentiation in little detail, all the important formulas. And if you are watching my initial videos, where I have covered in detail all the formulas which are possible, all formulas I have written and explained. So if you watch the basic mathematics videos where I have covered everything in this, that is more than sufficient. Okay, that is for advanced level also, from JEE main level to NEET level to advanced level. All formulas I have written, which you don't find in the book. Sometimes some formulas are not given in the book. Today also I was searching one formula I had to use, but I did not know. I forgot that formula. Then I had to see my video. That video I saw, there I have written all formulas. So all formulas are there. It is good to make list of all the formulas. Okay. Right. So let us go now into uniformly accelerated motion, and then we'll go to non-uniformly accelerated motion. We have to write equations. Okay. So uniformly accelerated motion. Uniformly accelerated. Uniformly accelerated motion. Uniformly accelerated motion means acceleration is constant, and we are discussing only in a straight line. So body is only moving in a straight line. It may change its direction left to right to left, but it is the same straight line. It is the same straight line. So here we need to understand that What are the important equations? There are 5 important equations we have to note. 1, 2, 3, 4, 5. I will list out all the 5 formulas. So first formula is V equal to U plus AT. Second formula is displacement delta x. Let us write as delta x. Displacement is equal to ut plus half at square. Third equation is v square equal to u square plus 2ax delta x. Then fourth equation is average velocity is equal to u plus v by 2. Now you will understand why this average is correct. Already we discussed yesterday why it is mathematical average, because the graph is a straight line, and this last one will be displacement in the nth second delta xn is equal to u plus e by 2 to n minus 1. So here what are these terms? I will here show in the diagram. So u means velocity, initial velocity when time is 0. Time is 0, this is initial velocity. What is v? V means final velocity. This body has got some velocity. So this is the final velocity v. And here time is t. Some time is there. What is displacement from initial to final? This is called displacement delta x. Delta x, you know, displacement is final position minus initial position. We have already done that. Okay. And this is the time. Acceleration a is the constant. What else is remaining? Everything is there. Yes. Over. So in this equation, tell me. Yes. This I will explain. This delta x and what it is, I will explain that. Okay, I'll explain. So first, did you understand this? What it is? U, V, A, T, delta x. What are all these things? Did you understand that? So first you understand what is this delta. Delta x is the displacement in t seconds and delta xn is displacement in nth second. Let us understand what it is. For example, suppose if you take time 0 to time 1, right, this is called first second. If you take time 1 to time 2, this is called second. If you take time t equal to time 3, this interval is called third second, like that. Okay, so in general, if I take nth second means what will be nth second? 0 to 1 is first second, 1 to 2 is second, 2 to 3 is third second. So in the same manner, if I take time n minus 1 to time n, this will be called nth second, right? Because 0 to 1 is first second, 1 to 2 is second, 3 to 4 will be 2 to 3 is third second, 3 to 4 will be fourth second. So final one will be the nth second. Like for example, 1 to 2 means it is second, 2 to 3 means third second. So n minus 1 to n will be nth second. Note that it is an interval of 1 second only, right? Because all these are interval of 1 second, 1 second, 1 second, 1 second. But which second it is? Is it because motion has started sometime? Now, which second are you want to calculate, things? Suppose you want to calculate displacement at the 10th second. 10th second means 9 to 10 second. It's an interval of 1 second, but from 9 to 10 second. Right? So that is what is this displacement. That is what is this displacement. Are you clear about this? And you can derive it. See, we will derive this, okay? So that you don't have any confusion. So displacement in n second, displacement will be what? This will be displacement in n second. Let us write this. This will be displacement of in n minus 1 second, and displacement in n second will be starting from 0 to last. This will be displacement in n seconds, correct? Okay, so displacement in n second will be this 0 to n, and displacement in n minus 1 will means 0 to n minus 1. So if you subtract these two, now you will get what is displacement in nth second. This you have to understand. If you subtract this you will get as displacement delta xn. Okay, so what is delta xn? Delta xn means displacement in n second minus displacement in n minus 1 second. Now you know the formula, let us apply that. So displacement of n second formula is ut plus half at square. So u, but time here is n, un plus half a n square minus this one u n minus 1 plus half a n minus 1 whole square. Now you solve this. So you need to solve it, okay? Solve this. Are you understanding this? I think your network is little bit slow. Mobile data, na? It is slow. You don't have Wi-Fi? Dipurna? Can you hear me? Network is slow little bit. Okay, fine. So did you understand this first? What is displacement in nth second means displacement in n second minus displacement in n minus 1 second. That small interval, that is what it is. So we can subtract it now and you can derive that formula. So when you subtract un will get cancelled. You will get from here u. Half an square will get cancelled. From here you solve it. If you want half a, you take common. So n square minus n minus 1 square. Right, a square, and that term also you open that. So this is n square minus n minus 1 whole square. Open this and check what do you get. So you get u plus e by 2 a square b square. You can do that, right? So a plus b, a minus b, a minus b when you do you'll get 1, a plus b when you do you'll get 2n minus 1, right? Are you clear? Okay, so this is the formula for displacement in the nth second displacement formula. Are you clear of all these formulas? So these 5 formulas we must remember. If you want to solve any question on this constant acceleration, these 5 formulas will work. Many shortcut formulas will come from here only, right? Suppose initial velocity is 0 and displacement is h, so v square equal to root ah, and acceleration is due to gravity, so root 2gh. We'll see that shortcut will come from Okay, so derivations are all derivations can be done using calculus, differential equations, or using the graphs. Graph differentiation you can easily understand for this case, so I will do for graph. Okay, using graph we can discuss that. So let us take graph and discuss that, because graph we have already covered. So let us say that this is velocity time graph. Now tell me, what is the slope of velocity time graph? Yesterday we discussed that. What is the slope of velocity time graph? Huh? What is the slope of velocity time graph? Slope of this graph is dv by dt, which is nothing but acceleration, which is here is a straight line. So this is tan theta, and tan theta means this distance, which is v minus u, and this distance, which is t. So from here you got the first equation, right? V minus u by t is a, so v minus u is equal to at. That is why v equal to u plus at. See, very easily you got the first equation. That's why graph, if you can, understand graph now, very difficult questions also can be solved. Because the tan theta, it's a straight line, so it's a constant slope. So if I take 0 second, its velocity is u, at t second, its velocity is v. So the difference here, v minus u, right? That's what it is. And it's a 90-degree, right? That's why in this triangle, tan theta, v minus u by t. You got the first equation. Second equation, I want to calculate displacement. Tell me, what is the area under this graph gives? What is the area under velocity time graph? Yesterday, you've seen. If you forget area, so remember area means integration. This integration of v dt. What does that mean? What does that mean? So that simply means that we know acceleration is equal to, sorry, velocity is equal to dx by dt. So v dt simply means dx, and when you integrate, it will give us displacement. So area under velocity time graph gives displacement. Yesterday we have seen that. So area under this graph means what? This area of this trapezium. This area will give us displacement. What will be this area? Tell me. Area, know how to calculate. We know how to calculate area. Trapezium it is. So this is u, this is v, parallel side, height is t. Calculate area, half into sum of parallel side, v plus u, into the height, which is t. That is what is x. Okay, right? We got this. That is the trapezium area, right? This is the area, trapezium area. Now from here v you can substitute here, substitute v. So v becomes u plus at, right? V is u plus at plus u into t is equal to x. Or if you want to write delta x, let's write this displacement as delta x. So now you open this bracket, so this will be half, this will be 2u, right? 2u plus at, 2u plus at into t is equal to delta x. So from here now you calculate. So it become, you open that ut plus half ut square. You got that, right? This is what is displacement. So finally we got the second equation. Equation number 2 also we got it. Second equation. Displacement delta x is ut plus half ut square, that is coming from area. Second equation is over. third equation. To look at the third equation, you don't have to do much, just to see this equation. Just look at this equation that we got from area. Look at this equation. And now what we will do is we will replace time. So from this equation, from this equation, v minus u by t is equal to what? X acceleration. So time becomes equal to v minus u by a. This substitution we will do here in this equation. Substitute that. So what do you get? Substitute. So half into v plus u. Time I will substitute as v minus u by a. And this is displacement delta x. Now you simplify this. What do you get? A plus b, a minus b become a square minus b square. And 2a in the denominator, you take that side, 2a delta x. That's how you are getting the third equation, v square equal to u square plus 2a delta x. Done. All the equation you got. Third equation, today we got three equation. Fourth equation, average velocity, we got yesterday. Straight line means mathematical average, u plus v by 2. Okay. And the fifth equation we also derived. So all the five equations, now you know the derivation from the graphs. Clear? Okay. Over. So this one is over. Now we can go for non-uniformly accelerated motion. Non-uniformly accelerated motion. Non-uniformly accelerated motion. In non-uniformly accelerated motion, acceleration is not constant. Then you cannot do any of these equations. Whatever equation just we saw, v equal to u plus at and all the five equation, none of this you can use. What you can use is differential equations. So there are only three differential equation. V is equal to dx by dt. Second equation is acceleration is equal to dv by dt. Third equation is acceleration is v dv by dx. All the question in physics can be solved. Kinematics questions can be solved using all the three equations. V equal to dv by dx by dt, acceleration is dv by dt, acceleration is v dv. Only thing that you need to know when to use this equation. One or two example I will discuss in this. Then this topic is over. Means motion types of motion will be over. Okay. Let's try to understand this with example. Suppose if I take let us take example that x is equal to t cube, t cube, 4t cube minus 2t square plus 5t plus 10. Okay, this is how the position is changing with time. This is how position changes with time. Question is find displacement from time 0 to time 10. This is the first part of the question. Second part of the question is find velocity at 10 seconds. Third part of question is find acceleration at 10 seconds. Fourth part of question is find average velocity at time average velocity from time 0 to time 10 second. Okay, same interval we are taking. Let us try to solve this. Okay, so let us try to solve these questions quickly. Quickly we will. Huh. Yeah. Yes, you have to substitute. So initially x1, let us say when time is 0, what will be? This is 0, this is 0, this is also 0, this is 10. So initial position is 10. What is final position? x2 you calculate when time is 10. So this is 4 into 10 cube minus 2 into 10 square plus 5 into 10 plus 10. How much? And you need to subtract. 4000 minus 200 minus 50 plus 10 plus 50 plus 10. I will keep this 10 as it is because we have to subtract 10. Okay, leave that 10. So how much? This is minus 150. 200 plus 50 is minus 150. So from 4000 you subtract 150. How much you'll get? 4000 and 150 I subtract. This is minus 1. 8 na, this is 38 na, 3850, correct? 3850, right? Correct na, 3850. Okay, so if you want you can add it also, but we want to calculate displacement, means final minus initial, x2 minus x1. That's why this 10 anyway will go away when you subtract. So the answer will be 3850 meters. Everything is in meter SI unit. Clear? Okay. Over now. Then next, second solve. Velocity at 10 second will be what? 10 second velocity calculate, differentiate x. Calculate. Velocity is dx by dt. Can you tell me the answer? Do it fast. Differentiate the first term. So 4 comes out. T cube differentiation is 3t square. Minus 2 leave it. T square differentiation is 2t. Plus 5 you leave it. T differentiation with t is 1. Constant differentiation 0. So you got velocity. Velocity is 12t square. How much? Right? That's what is velocity. Substitute 10. Substitute 10 and get the answer. 10 you substitute. So 12 into 10, 1200 it will come. Minus 40 plus 5. So we'll get what the answer? Minus 35. 35 you have to subtract. So 1165 meter per second. Correct? Then acceleration you have to calculate. Calculate acceleration. So to calculate acceleration we have to differentiate velocity. Velocity, this is the velocity in terms of time which we have got it here. Now you differentiate once more. So leave 12 t square differentiation 2t minus leave 4 time differentiation 1. Constant differentiation is 0. 24t minus 4. So time you substitute and they are asking at 10 second. So acceleration will be 240 minus 4. 236 meter per second square, right? We got it. Then last one, average. Now you tell me average I will calculate. Which formula you will use? How will you calculate average? Hmm? Yes, Ritupurna. What is your answer? Come on, tell me. Which formula you will use? Yes? Can you hear me? No formula, basic definition. Average velocity basic definition is displacement by time. Why are you thinking formulas? Displacement by time. So displacement already you have calculated for 10 seconds. This is what it is, 3850. By time interval is 10 seconds. Yesterday I gave formula, but see this formula was based on this definition only. See, yesterday I told you now this average velocity is what? Displacement, which is integration of v dt by delta t from time t1 to time t2. This integration of v dt is nothing but area of that graph, now vt graph area, that is displacement only. So this is the basic definition. Average velocity means total displacement by time, and total displacement we have already calculated it. We cannot use u plus v by 2, u plus mathematical average we cannot take. Mathematical average, why cannot we take? Tell me. Why cannot we take mathematical average? Ah, yes, yes. Mm, mm, mm. Yes. So if the velocity time graph is a straight line, then you can take mathematical average. Velocity time graph, straight line, but it is not a straight line. Why? Because a straight line means constant acceleration. Straight line means uniform acceleration. But in this case, acceleration is not uniform. Why? Because acceleration is where we calculated acceleration here. Yes, acceleration depends on time. You can see that acceleration is 24t minus 4. So acceleration changes with time. It is not a constant acceleration. That is why we cannot use this u plus v by 2, because u and v we have already calculated initial and final velocity. You check also how much it is coming. Initial plus final by 2 is how much? Velocity we have calculated here, right? 1165. When you substitute an initial velocity, you can also calculate by substituting 005. So initial velocity is 5, right? And final velocity is 1165. So when you add initial and final, 1165 plus 5, 1170, 1170. 1170 by 2 is how much? 1170 by 2 is how much? 1165 plus 5 divided by 2 is 1170 by 2 is 2510 26 no 2816 2816 2510 meter per second. This is not the correct answer. You have to note that this is not the average velocity. Why? Because acceleration is why because acceleration is not constant. Acceleration is not constant. Okay, this is the simple reason. Are you clear about this? Yes. Okay, done. So I think now you have understood. And there are certain results in uniform motion. I will quickly write some of these results which are used in NEET. Okay, mostly. So for uniform motion, there are few results that I will write. Uniform motion means same velocity. So there are some cases like case 1 you can take that body or particle travels equal distances equal distances equal distances with different velocities, or you can say speeds also. In this case is like, suppose a particle is going, or let us say a bus or a car is there, is going like, first equal distances. Let us say the distances are x x is the distance here. Okay, x like that it is traveling, but during each here to here the speed is v1. Let us say here speed is v1, here to here speed is v2, or you can take velocity also. Similarly, here to here velocity is different, v3. Here to here velocity is v4. Like that it is going, and the last motion you can take as vn. N motions it is happening. Okay, and n motions are it is. Maybe first time he is going by cycle, then he is going by car, then he is going by bus, then he is going by train, then he is going by different, right? So he has got different distances, but he's traveling equal distances. So here they will ask what is average velocity or average speed. So how do you calculate that? Again, remember the average calculation is total displacement by total time. So total displacement is x. You have to add them. So 1x, 2x, 3x, like that. Total distance will be n into x. And time you have to calculate. So time, how will you calculate it? So this time is t1, this time is t2, right? Like that. This time is t3, this time is t4, and this time is tn. So you need to add all that time, okay? T1 plus T2 plus all that time up to that last time. So n into x. Now, what will be the time? You remember all these motions are uniform motions, so speed equal to distance by time. So time is distance by speed. So this time T1 is distance by speed V1. This time is distance by speed V2. This time is distance by speed V3. Like that, you have to keep on doing like this till last. Distance by speed Vn. And now you can cancel out this xx. This x will get cancelled here. So you will get the average velocity formula or average speed formula as n divided by 1 by v1 plus 1 by v2 plus dot plus 1 by v. What? Yeah, they will give. They will say that the body travels first time with this speed and second time with this speed. So that means two only you have to take, right? N will be two. And if they say body first travels with this speed, then it travels with this speed, then it travels with this speed, then what is average? So that means three times you have to take. Okay, so n represent how many different speeds are there. Okay, depending on that you have to do calculation. We'll see questions. No, if I take, yeah, if I take up to this much, then it will be 4, or if I take only 2, then it will be 2. So this is a general formula. Okay, let's take one question on this, then you will understand. Suppose a car is there and this car travels equal distances with speeds 120 kilometers per hour and 200 kilometers per hour. Okay, or let us write this as 240 kilometers per hour. Find the average speed. Find average speed. Okay, so directly use this. So two times only you have to calculate, because one time it is going with some speed and next time it is going with different speed, right? But distances are equal only. So directly we will use this formula. Average will be equal to, n means 2 here, 2 divided by 1 by 120 plus 1 by 240. Answer will be in the same unit, kilometer per hour. This we can calculate, right? So take LCM in the denominator, which will be 240. 240 will come here and here it will be 2 plus 1 3, so it will become 3, right? Then you cancel out. So 3 into 8, 80, 160 it will become. The answer will be 160 kilometer per hour. Clear? Okay, that's what it is. So this is first type of means case, and second case they will give is equal time. Body travels in equal time. Case 2. Body travels in equal time with different with different speeds. So here also same thing. Body is traveling first with a speed v1 in time t. Next it is traveling with the speed v2 with time t. Next it is traveling v3 with time t. Like that it will continue. Okay, I am taking for another last one, general. Vn with time t. So there are n number of motions are there. What is the average? So when you have to calculate average here, again the formula is going to be same. Average formula is total distance by total time. Let us say the distance here is x1, x2, x3, right, up to xn. So you need to add the total distance x1 plus x2 plus x3, right, dot plus xn. Total distance by total time t and t it will come, right, sum of all the time. Now you will use the formula distance is speed into time because each is uniform motion. So distance x1 will become speed into time, it will become v1 into t. Second, x2 will become v2 into t. x3 will become v3 into t. Like that it will become, last one will become vn into t divided by n times t. Now here you will cancel out t. T will get cancelled here, each term. So this is what is mathematical average. Okay, this is mathematical average. V1 plus V2 plus plus Vn divided by n. This average velocity. So if the body travels equal time, then you can use mathematical average. But remember, all the derivations are done for uniform speeds. Uniform. Here it's uniform. Here also uniform. Here also uniform. Each motion, small motion, is a uniform motion. That's how you can do it. Okay. Different time with equal speed. If all the speeds are equal, then it is a speed. It is not at all changing. Right, speed is not at all changing. So if speed doesn't change, whatever speed is, that is the average only now. Right. Suppose you are driving and you are not changing your speed. If you are not changing your speed, whatever is average, that is the same speed, because there is no different speed, right? Okay. So if speed doesn't change, if speed is constant, this already we also noted this previously. If you remember, previously we have noted, if this speed is constant, that constant itself is the average speed for any interval you take. Do you remember? I think you will remember this very clearly. If I draw the xt graph and let us say the graph is a straight line, so tell me, is the velocity constant or not? And if velocity is constant, then what is meant by average? Average means delta x by delta t, the slope. So this is like delta x and this is delta t. That angle is theta. So that delta x by delta t, that is what it is, average. And that average is tan theta. And tan theta is also the instantaneous velocity, because anywhere if you take a tangent, any point you take a tangent, that tangent will be the same line itself. Tangent will be the same line anywhere you draw a tangent, right? So here in this case, this dy by dx by dt is also the same. Dx by dt is same. So delta x by delta t or dx by dt is same. So average velocity and instantaneous velocity are same if velocity is not changing, right? But you can say one case where they can combine the first and second cases. They say that first it is traveling with equal distances, then it travels with equal time. Then you need to calculate average. Then you need to. Hmm, hmm. I think so. We can do that. Yes. We can take average of both and then take average of both the values in that case. That will work out. Okay. So first, let us that also case write it. third case 3. So equal distances plus combined with equal time. Suppose for example the body travels with v1 and v2 and v3. Let us take this 3 only. Equal distance x x x. Okay. After that body travels with v4, v5, but now time are equal. Let us take 3, v6. But now times are equal, t t t. Okay. Times are equal. So in this case, what we will do? We'll calculate average for this one. This average we can calculate. What will be this average? Calculate. This average will be 3, right? It will be 3. 3 motions are there. So it will be 3 divided by 1 by v1 plus 1 by v2 plus 1 by v3. We'll calculate this next. For this average, this average will be what? This average will be mathematical average v4, v5, v6 by 3, right? After that, so we have done average for this, then we can take mathematical average or not. Can we take mathematical average? Yes, I think so. We can do mathematical average now. Now we can take mathematical average. So now let us take mathematical average. So combine of these two, then the final average for entire motion, final average velocity for entire motion will be this average plus this average by 2. Let us take this average 1 and this average 2. So average 1 plus average 2 divided by 2. So we can do that. Divide. So I will just write it here. So this 3 divided by 1 by v1 plus 1 by v2 plus 1 by v3 plus v4 plus v5 plus v6 by 3. This sum of these two divided by 2. Finally, we will divide it. Okay. This operation you have to do, then you will get the average for the entire motion. You will get an average. Clear? So you can combine it also, right? Done. Okay, so we have finished this. Then what is remaining is motion under gravity. Quickly we will do motion under gravity, then relative motion. Okay, let us finish 15 minutes. After that, today we will finish this chapter. Then I will recommend you that you must go through my this video on NCRT solutions first. Okay, so I have taken sufficient time to make NCRT exercise old NCRT. So there are 3 videos up till now. I have covered all the old NCRT including the exemplar questions. Exemplar NCRT, exemplar also I have covered, but in the exemplar the subjective last part I have not covered. I will also make that video. Subjective question, that is quite complex question, advanced level question it is. I will make for that also. Okay, but you can watch, 3 parts are there. If you can do it, that means whole concept will be clear. After that you can now work out problems. So I will also share you link for the problems on motion in straight line. You can write, right? Test, definitely you should give test, then only I can understand how much your performance is. Okay, then let's go. this motion under gravity. Motion under gravity. Motion under gravity means this is also called free fall. Free fall. Free fall means if you leave a body, it is going falling due to gravity. So the acceleration is acceleration due to gravity, which is 9.8 meter per second square near surface of Earth, near surface of Earth, and it is in downward direction toward the center of the Earth. This acceleration is always toward the center of Earth downward. Okay. So the questions that they will give is only you can use G value 9.8, but sometimes they will give the value of GS10, so you have to use that GS10. So note that acceleration is constant here. So acceleration is constant means it is a uniformly accelerated motion. Uniformly accelerated motion. Now you can apply all the formulas for uniformly accelerated motion. All the 5 formulas you can apply. V equal to U plus ATS is UT plus half AT square, all those. Everything can be applied. But I will give you the important cases, okay? The derivations are there. In the videos also I have done that. You can watch that. We will share that link also. So first case is that, first case here, motion under gravity. Suppose from the ground, if you throw a body, upward with a velocity u, the question is how much height it will go, maximum height, because at some point its speed will become 0. Okay, so this height we are calling as maximum height. That is the maximum height. Maximum height. Its speed will become 0. So what is the maximum height and how much time it will take to go? Suppose you throw at time 0, at some time t it will reach here. So how much time? So direct formula you have to remember, h is equal to u square by 2g height. Time formula is total time. Okay, this is time of ascent. Okay, I will write this as time of ascent. Time of ascent means how much time it takes to go up and then come down. So from here to here it will go, here to here it will take a time of ascent, and then again it will come down. This will take a time of descent. So time of ascent TA is called time of ascent. Time of ascent. And TD is called time of descent. Time of descent. So how much time? Total time is time of ascent plus time of descent. This is called time of flight. Time of flight. So time of ascent is u by g and time of descent is also u by g. So total time of flight becomes 2u by g. This also you have to remember. So time of ascent or time of descent both is equal to u by g, u by g. That's the only formula you have to apply here. Time of ascent, time of descent are equal. This is the total time and the maximum height. So this is case 1 which you have to remember. Next, case 2. Case 2. Case 2 is that you are now dropping the body from some building of height capital H. You are dropping it. Drop. So drop means initial velocity 0. So the question is, when this body will reach the ground, what will be its speed and what is the time taken to reach the ground? Total time, that is the descent only. This is the time, how much it is there. So let's write down this formula. So this time will be root under 2h by g, and this velocity with which it will reach here is root under 2gh. This velocity will be root under 2gh. Okay, so you have to remember these two formulas here. That's all. The third case, what is the third case? Third case is that you are throwing it. Instead of dropping, you are throwing it from this building, of height h. You are throwing that body with some speed u. Then again, same thing you have to calculate. They will ask to calculate what is the time taken and what is the final speed here, v. Okay. So note that in this case, the final speed v will be calculated as root under u square plus 2gh, and the time will be calculated as v minus u by g. V you can substitute here. Okay. This is the case 3. What is the case 4? Case 4 is that you are throwing it upward from the building. Case 4 is from a building of height h, you are going to throw it up with a velocity u. So here it will go up and then stop here because velocity will become 0 and again it will be coming backward. So again they can ask that what is the velocity at the bottom. Remember, velocity formula remains same, u square plus 2gh. But now this time 0 you have thrown it and time t is equal to t, it has reached the ground. This time is the time of flight. Now this time will be more. Why? Because it has to go up and then come down. Here you were throwing directly, it was coming down. So this time the time of flight formula is v plus u by g. Very simple to remember. Okay, v plus u by g, here v minus u by g. Very simple to remember. If you remember these simple formulas, you can solve complex problems. Okay. Right. If you remember this simple formula, you can solve complex problem, difficult question. The last case is to do little bit complex problem. Last case. In the last case, you are throwing a particle from ground. Okay, let us say from ground, you are throwing a particle body. You are throwing from ground with some speed u. So it will go up, and here it will speed will become 0 and again it will come back. So there is a particular level, this height, let us say this height is y, total height may be h, total height may be capital H, let us say maximum height, but there is a level y where it is crossing two times, one while going up, one while coming down. Okay, and let us say here velocity is v. So while going up same speed and while going down same speed remains at that level. Okay, so the question is that let us say time 0 you have thrown it and here it is time equal to t1, it is reaching here, and time t equal to t2, it is reaching here. They can ask what is the time difference t2 minus t1. What is the time difference t2 minus t1? Right? They will ask this t2 minus t1. Or they will give you t2 minus t1, they will ask what is y. So note that this t2 minus t1 can be just studied by thinking of this level. This time of flight you can just see this level. How will you calculate this? This is the time of flight from the ground, right? Only thing is that you need to know what is v. And note here at this level, this speed v is given as, root under u square minus 2gh. H means this y at this level. Okay. This interval t2 minus t1, which you can write as delta t, this interval can be calculated as time of flight for this, which will be 2v by g. 2v by g. And this 2v you can substitute from here as root under u square minus 2gh, 2gy by g. Okay. and now you can do some calculations here. This delta t is equal to, I will just write this formula, 2 root under u square minus 2gy divided by g. Okay, this is what it is. Clear? And there are another approach to solve this question. This of course the shortcut, but there is one more approach to solve this question. There is one more approach to solve that question, that also I will discuss. That one approach will be, let us say this is the displacement, so write the formula for displacement. Y is ut plus half ut square, but here you have to write as minus half gt square, because here from here to here when you are writing, acceleration is opposite, acceleration is downward g and upward motion is upward. So you choose upward direction as positive and downward direction as negative, right? So there should be no confusion in sign convention. I think many students get confused with sign here. Okay, many students get confused with sign. Why? Because sometimes they will take one direction as positive, sometimes they will take other direction as positive. They confuse it. So you need to consider here only one direction positive, other direction will be negative. Suppose if I choose upward as positive, then downward we have to choose as negative. We cannot change every time. Okay, we should not change, otherwise confusion will happen. The choice is yours. If you choose upward as positive, downward will be negative. But if you choose upward as negative, then downward will be positive. Okay, one time only you have to make choice, again and again you cannot change that. Okay, so you have to make one time. So in this problem we are choosing upward positive, downward negative. So this is why y is equal to ut plus half ut square. So now let us note that you will get a quadratic equation in t. You will get quadratic equation. Try to make a quadratic equation. 2y is equal to 2ut minus gt square. So gt square minus 2ut plus 2y is equal to 0. Okay, so some notification is coming. Okay, so you get this quadratic equation. So tell me, what is the sum of the roots and what is the product of roots? You know the quadratic equation. Tell me, sum of roots and product of roots. Yes, what is the sum of roots? Sum of roots you know or not? Quadratic equation. No, no. See, sum of roots is minus b by a. You know now, this is b here minus. So this is 2u by g, and product of root is c by a. So 2y by g. This you have to note. Okay. This is the shortcut you will use in problems in NEET. They will ask a lot of problems with this. They will give you the time t1 t2. They will ask what is that height it is crossing at t1 t2. 2 time instant it is crossing. They will give you 3 second, 4 second. It is crossing a height. What is that height? You will use this formula to calculate y. Understood? Or they will give t1 t2 and they will say what is the initial speed which we are throwing it. From here you can calculate. From here u will be g by 2 t1 plus t2, and from here y will be, that height y will be g by 2 t1 t2. This is a very very important formula in NEET. It is used. Okay, immediately within few 1 second you will solve this if you know this. Okay, let's take one example. Suppose they say that a ball is thrown like this with some speed. It's going, and it is going some height. They are saying that it is crossing some level. It is crossing while going up, and while coming down it is crossing that level. What is that level? Okay, what is that? This is ground, and what is this level? Why they will ask to calculate. They will give that it is crossing at time t1 2 second and t2 4 second. Find out the height. Directly you will use this formula. Y will be g by 2 t1 into t2, so 2 into 4. This get cancelled, 4g. If you take g as 10, so approximately it will become 40 meter. So it is crossing 40 meter right now. Okay, maximum height may be larger, that we don't bother, but this height they will ask. Clear? And also note that this t1 plus t2 is also the total time. Okay, so t1 plus t2 is the 2u by g. It is the total time formula. This is the total time of flight. Total time of flight. So over motion under gravity over. Now just 5 minutes I'll cover that relative motion. Okay, just 5 minutes. Did you take your dinner? Then you will get late now. Okay, let us keep that for next class. Otherwise, it will become late. So then we'll see next class relative motion, separate class will do. So today we have completed almost everything, all the formulas, all important results. Now you can start working out question. Relative motion you can leave it. You can work all other topics in motion in a straight line. Fine. Then we'll see next class on what problems we can see. On this we can work out problem. You solve question and give doubts. You can send me doubts, or in the class you can share doubts. We will discuss. Okay, fine. Then we'll see next class. Bye bye.